So today we are going to solve this problem B of Coders Educational DP Contest, Frog 2. So the problem statement is that there are n stones numbered 1 to n. For each I, the height of stone I is hi. There is a frog who is initially on stone 1. He will repeat the following action some number of times to reach stone n. If the frog is currently on stone I, jumps to one of the following stone I plus 1, I plus 2 till I plus k. Here a cost of hi minus hj is incurred, where j is the stone to land on. Find the minimum possible total cost incurred before the frog reaches stone n. So, what's the difference in this question from the frog 1 question? Here we were given the two states only. Like he can jump to I plus 1 and I plus 2. But now, in this second problem, we are given that he can jump from I plus 1 to I plus k. So it is sure, like intuitively, I can think that now I would require to apply a for loop to check all the possibilities of k paths. So let's first take the input from the user. N is the number of stones, and let's store this stone in an height of the stone in array are I equal to 0, I less than n, I plus plus c in array I. So yes, we have stored the array. We have stored the height of the stone in the array. Now, similarly, I can declare a helper function. Like we are going to approach this solution in four or three ways. Like first, we are going to think the recursive approach. Then we are going to optimize it by converting into by by memoizing it, and then we are going to tabulate it, and finally, if possible, try to space optimize it. So for int I, and I need to pass this vector array by reference vector int ampersand array. So what does my helper function represent? My helper function represent, if I am calling helper I, then it is going to return me the minimum cost incurred till reaching index I. So at final, I am going to call return helper n minus 1 in cost equal to helper n minus 1, and then I am going to see out the cost, and that's it. Now I just need to think the logic for this helper function. I'm going to go from n minus 1 to 0. So my base case is going to be 0. So if I is going to be 0, then you should return uh, 0. Like cost incurred at index 0 is 0. It is given to us because initially the frog was on index 0. Now, looping through all the paths possible. Okay, so int cost equal to int max for int I equal to 0, I less than n, I plus plus, I equal to 1 till k. So I think we would be given two things here, and I should pass k also, int k. So my cost is going to be minimum of cost, comma, I should apply an if condition here. If, if I minus, oh, I should not declare I here, j and j. So if I minus j is greater than equal to 0, then my cost is going to be minimum of what is the current cost and the absolute of array I minus array I minus j plus the helper function of I minus j array and k. So according to me, it should work. And then I'm going to return the cost. Okay. Now this is the recursive solution. I need to optimize it. So I will declare uh, a vector dp, vector int dp and comma minus 1 and comma minus 1. And then and now what to do? Now I will pass this dp here. Let's pass this dp here also. And where else it is required? Here. Now it's fine. Okay, it is initialized perfectly. Now, if my dpi is not equal to minus 1, then I would return dpi. Okay, looks good. And here I would store my dpi equal to cost. Put split, and it is calling itself. So it looks perfectly fine. Let's just copy the test case and try to run it over here. Is there any error that I could find? In my view, it is correct. Let's see if it matches. No. Where's the problem then? Uh, If I equal to 0, then return 0. If dpi is not equal to tk, this is fine. If I have defined the cost and initially it is initialized to max, I'm looping from j equal to 1 to j less than equal to k. See, yes. So the problem here was that I was not going till index k, I minus k. It was only going till I minus k minus 1. So this was the small mistake here. Now let us just submit our code. Open file, desktop, code forces, dp, question 2. Submit. Let's hope for the best. Yes, it got submitted. Now we should optimize it by using tabulation. Initially, right now the time complexity is uh, O of n plus k, because we are running a loop inside it, and and uh, and it is running. It is the tree's max length is going to be n, so n plus k or n into k, you can say. Let us run this. It is n into k, I guess. Yes. Now let us try to convert this into an what? Tabulation form. So the base case is still dp0 equal to 0. For loop, we are going to run the for loop in the same way. Initially, we were running in recursive format. When we were doing a recursion, we were running the for loop from n minus 1 to 0. So if we are converting this into a tabulation, then we need to go from bottom to up. So we will run this loop from 0 to n minus 1. But as the base case has covered the case of 0, so we are going to skip it in the for loop. We are going to run this for loop from I equal to 1 and I less than n I plus plus. Now here I could simply copy this recursive solution and paste it here. Tab int cost. This remains the same. The change that comes is here dpi minus j, and just remove it, and dp I, and here we are going to return dp and minus 1. Let's see if this case runs well. Yes, it is running well and good. So we are going to submit this code here. Yes. So what we did is, by converting this solution into tabulation format, we have reduced our time space complexity from O of n to O of it is still O of n only, but the stack that was earlier created in the space that was created in the stack when we were doing recursion, now that stack is not created. So that small space complexity we have uh, saved. So thank you for watching this video.